There you go.
Should I just go then?
Yeah, I guess I'll just say welcome to our study hall, everybody.
Okay, wonderful. Yeah, welcome. And thank you again for letting me speak here. It's an honor, and I'm glad to have so many interested R folks here, especially as what I have to show you is potentially a little less R-y and more Lakehouse-y, but there's definitely R involved, and I'm excited to show you what we have. At the risk of repeating what happened a couple weeks ago, but just to refresh our minds, I'll just lay some context here. As you may know, the CDPHE, public health site anyway, is building a data lakehouse to pull data from many diverse systems into a single place. And although when it's talked about, it's mostly about bringing data into a single environment, probably from a technical standpoint, it's better to understand it as just creating a new and more powerful analytic environment for CDPHE users. So it doesn't stop at all the data's on one database. We are also creating a scheduler, a place for you all to share files and collaborate on workflows, places to access stronger compute resources, things like that. So I'll be pointing some of those out to you here as we go. I should also mention that it is still under development, so there are certain facets that I'll mention to you and be like, okay, this part is still being worked on, but we're pretty close, and I'm pretty confident so far with what we've built. I'm pretty excited, and I should also mention that I'm getting over an illness, so hopefully I'm not, delirious and saying rat crazy things here. So cool. All right, I will share my screen and let's get going. So, just to give you a sense of the lay of the land, the Lakehouse has, I don't know, it depends how you count, but maybe 4 key elements that you want to be aware of. So one of them, and the first one you'll encounter, is called Core. So that's the name of this application I'm in right now. You can access it through a URL. You'll log in with an account that's been provided to you. Core does a lot of different things. It allows you to create sort of projects where you can collaborate on certain file sets, but it also accesses to your local, your personal virtual machine. So if you get into Core, if it's not running, you can just press start, but then you press open virtual machine and voila, reconnect to it. Give me a second. Okay. Yeah, so when you're in your virtual machine, it's basically just Windows right here, doing what Windows does. But instead of being hosted on your physical laptops, RAM and memory and so on, it's hosted on Google's hardware. So if we wanted to, we can allocate greater resources to it as necessary. Okay, so that's Core, that's your virtual machine. Now your virtual machine is sort of your portal to accessing a greater functionality. One of those is the actual data that the Lakehouse stores. You'll recall I mentioned that we're bringing a lot of data from different sources into one. The first step there is immunization records and disease surveillance, but really sky's the limit, and there's at least 3 others planned for the next 6 to 9 months. And those are all housed in Google's big data technology. It's called BigQuery, and you can see them over here. It's if you're familiar with SQL Server, it's really very similar. There are databases. They're called data sets at BigQuery, but there's databases, tables, views, columns, etc. Right? And then the 4th key element of the Lakehouse is called Jupyter Hub, or sometimes Jupyter Lab. And that is the analytic environment where you can allocate specific compute resources to your work. So if you go to Jupyter Lab, you can see different elements that you can launch. I presume because this is the R study hall, you'll want to use R. So you can launch RStudio, and you can see I've got my RStudio running over here, where I've got an RStudio instance. Now, notice this does not use my local machine's compute. It does not even use the virtual machine's compute. It uses Jupyter Hub's compute, which can be allocated more powerfully than your local machine or your VM might need. All right, so this is also I should mention it is shared. So over here, you can see there's a file structure and one of the folders is shared. This file structure corresponds to a project in Core. So I've got an active project on my virtual machine. That's the COVID test one. And over here, you can see the COVID test workspace. I've added certain people to it who can work on it with me. They can now attach it to their own virtual machine. These data sets are like external files you can upload to there. You can upload other files directly as well. You can export files from that project. We'll go into that in a little more detail later, but this shared file structure is associated with that project, so you can grant people access to it, take access away by kicking them in and pulling them out of Core. Yeah, go ahead, Nicole.
Yeah, I was sort of digesting some of the presentations yesterday that were shown, but one question I had about this piece was, so I know when R is on my regular computer or even the virtual machine, I can go into my documents folder and I can follow the path and I can find where this is living on my computer. Like the folders that you're showing right here, if this were on my computer, I could go into my documents and find exactly where those are and manipulate the folders. When it's in the Jupyter notebook, is there like a navigation to get to those folders outside of seeing them in the RStudio environment right now?
Yeah, so they're not shared with like your main file explorer, like they're not in your documents. I don't think you can, and I'll triple check this, but I don't think you can like go up a folder and back down some folders and land here. However, you can access these folders without going through the Jupyter Hub interface. That's done using the core file service explorer here. So if you open that one, you can go, I'm in an immunization project right now. So if you go to projects, sorry, this one's associated with my user. Yeah, so we have the different users and their files, and then maybe am I communicable disease? Oh no, I'm CDPHE done. And then you can see this is the COVID test project here. And those are the same files you just saw.
Okay, so interesting. Thank you. So it's like a drive, and is this a drive that is shared with everybody in the Data Lakehouse? And then you just like get permissions per project?
You can think of it that way. So like this upper echelon is in some sense available to everyone, but just like our shared drives on your like K drive, J drive, once you start down, other people can't. So I have access to this project folder COVID test, but actually only me, Sebastian, Diane have that. And if you tried to go there, you couldn't. I would have to like add you as a user to the project.
Okay, thank you. Yeah, that's good to know. And I think we have one question in the chat, which is if there's like a Google Drive connection anywhere there in that Jupyter piece.
Yeah, you can, as long as you use the right Google library, connect to Google Drive from here. I should note your Drive account, you have two Google accounts in this environment. You have the cloud account for the Lakehouse, but you can as easily go to your personal state account. And you can see I've got that here. Actually, I should close this so you don't record my emails. But, oh, dang it, I close it all. But you get the idea. There's another version of me over here. And this is all my bookmarks for my state account, and you can see the state account there. So you could connect to either of them, presumably with the right library and the right credentials and that kind of thing.
So more like a Google Sheets connection back and forth.
Yeah, so I haven't done that much of it right here, to be honest. But if you had a library, I think there's like Google Sheets 4, I think is one of the that kind of thing. And you have to like pass credentials to say who you are. But once you do so, you can go through all the Google Drive file structure and drop the results of your R work into that if you want to.
Got it. Okay, thank you. Sorry. I will stop the interruptions now.
No problem. Yeah, cool. Feel free to ask any questions as we go, by the way. I am happy to answer them. Okay, so last time I went through some of this code that I had written. You can refer to the video if you want more details on it. I thought today I would show you guys a bit of how to schedule tasks and potentially like upload and export files from Core. Go through some of the use cases that we imagined for that. So before we can automate anything, you need a task at all. So here is the same task you saw last week. I'll just run through it real quick. It just loads a bunch of libraries as a first step. And the overall goal is to take data from different sources online, parse it, format it properly, and upload it to BigQuery, where it can be combined with other data sources such as EpiTrax or the immunization database, right? So that's already housed in BigQuery. If you upload this there, you could build a dashboard that has both, right? Just by pointing Tableau to BigQuery. All right, the way it does it, you got a URL for the data. You read it using the Socrata. Just do some dplyr stuff. Down here, you'll see that I basically create 3 different data frames using some manipulations. And then I have to get to BigQuery from within R. So this part is probably the bit that's more interesting. So I use this package just called Big R Query. There are others if you want to explore them, and feel free, but this one has proven useful. So all you got to do at first is just type BQ auth, and you don't actually have to pass credentials because by default you are using a service account that's set up and linked from this environment to BigQuery and has permissions that match your own.
Sorry, real quick. So for that is the case if I'm in Jupyter Notebook or my virtual machine.
Good question. That's the case if you're in Jupyter Notebook. If you opened RStudio just from the desktop of your virtual machine, you would not have that because it would just be, you know, Nicole's RStudio, no different than if you had done it on your local machine.
Okay, got it.
Good question. Okay, and then I just sort of name some strings so that I can easily reference them. And then down here in each of these blocks, you can see the same pattern. I give a table name. Then I create a BigQuery table object using some of those parameters, the project ID, the dataset name, and the table name. And then I delete the existing copy of it, and I create the new one using the table object and these fields. Now, BQ table create, this method only creates the shell of the table, like the columns, the data types, that's it. You need also to upload the actual values, and that's what the last line here does, BQ table upload. So it takes the table and it takes the values from one of the data frames and uploads them. You can see the same pattern in the next one for the second data frame. And here in the third one, I was running into some issues with data types, so I just specified them manually instead of reading them from the data frame itself. Cool. Okay. Why don't we run this real quick? It should take maybe 2 minutes and you can see the output. Might be interesting. So what we're looking for is in BigQuery, this set of 3 tables, you'll notice there's an Infomart CDB named here. Yeah, I guess while this is running, this is a good chance to go through how things are organized in BigQuery. So the data flows in from the different data sources. It lands in the raw vault. Now, this is not just a cool sounding name. This is supposed to indicate real facts about the data. It's raw because this is the original data in its native status, not really manipulated. We're not cleaning it up much. What we are doing is changing the data structure. So the tables and columns in the raw vault do not match the data tables and columns in the source application databases. They are formatted for analytics. So data vault modeling is a modeling technique developed to create analytic databases where the tables and columns are organized and structured in a way that is conceptually understandable, prevents excessive joins, right? You don't have to join to look up IDs to get human readable values. That's all done for you on this in the vault. Yeah, so we have the raw vault in here, and then the raw vault houses the entire history of everything, and it's raw, so you probably want the business vault where business usable data is in the same data structure, but now a little standardized, a little cleaned up and useful. Now the raw vault and the business vault are where the data from the different sources flows into. However, we wanted to provide all of you with your own databases to work in. And so that's what these different infomarts are. So there's one for communicable disease, one for health equity, one for immunization. And really, if we wanted to create more, it would be pretty trivial. In fact, I've lately been thinking that communicable disease is quite a large umbrella. Maybe we need one for COVID, one for zoonosis, one for viral respiratory, that kind of thing. But anyway, these are just empty as of now. And whichever team wants, you can just upload, create tables, do whatever you want in there. This is sort of your database where you have admin rights. Sometimes you can build views built off of the Business Vault to create data sets that are useful for your work, because you might not want it in this format, or you can create tables from files, that kind of thing, whatever works for you. And I should say, you don't necessarily need to be a immunization or disease surveillance kind of person to use this. If you are, I think I saw some people from HICCUP, for example, here, or other people around CDPHE, you just want to have your own little database, just send me an email and let's talk about it, because it's pretty easy for us to create an infomart for you. Okay, let's see if this thing has finished. Yes, it has. So you can see down here the results, input, 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 output, output, output. It created those 3 BigQuery tables. Now, if we go over to those tables in BigQuery, we can also just take a look at them. If you check details, you can see that this table was created about a minute ago, which is what we would have expected, right? And then same here. Oops. Details. Yeah, good. Okay. So far we've shown that our script works. Now let's make sure that we can automate it, right? That's the part that is interesting. So the automation works in a slightly different way. Just to make things confusing, it runs in a separate Jupyter Hub instance. Now there's a reason for that, and that's because we wanted to make sure that automation of tasks was not local to a specific user, right? There's a lot of scenarios where, if I schedule a bunch of tasks, then I go out of the office and something breaks, you can't see my tasks, you can't fix them, right? And you cannot audit all the tasks that are running under your organization's header. Maybe you schedule the same one as me, and now we're bumping into each other, doing the same thing twice, getting confused, right? So what we did is we created organization level accounts that can schedule tasks on behalf of the organization. And as a result, there's a separate Jupyter instance for them, but also as a result, one organization like immunization, communicable disease can see every task under their header and check their statuses and review what's going on when. So the way you access that is through the virtual machine, of course. There's Jupyter Hub that gets you to your own RStudio kind of area, but then there's the job scheduler. And if you open that one, it'll take you to another instance of Jupyter Lab. You'll see it looks just like this one did, but the key difference is over here, it says JHub UAT Core Cloud User Me, right, in the URL. Whereas over here, you can see that this is the immunization one, by the way of the URL. Okay, now the scheduler cannot schedule our scripts natively from RStudio, unfortunately. So there is a slight limitation. You can't just like click schedule. But what you can do is go to, how do I say, you just have to schedule a notebook instead. I don't know if you guys are familiar with notebooks, but I'm sure you are. It's not exactly crazy. All you got to do is create a new notebook. It's going to have the IPyNB extension, but don't be fooled. It doesn't have to be Python. When you select a kernel, just make sure to select R, and it's going to run R code. So select the kernel, and then you just take the script that you had over here and dump it over here. And you can double check that it's working. You can just run it again. This is just some stuff about packages. Yeah, if you wanted to, you could break this out into different cells to make sure which cells are working when. When you automate this, it'll run the whole thing. You could, if you wanted to, you could do your development work in this environment if you really like cells and stuff. I wouldn't recommend it though, because again, this is a shared environment for everyone in your unit. And what you're doing here, if it's messy, you're going to maybe mess someone else up. So the workflow we imagine is you and your team in a given project. So if like the COVID team could work in this shared environment, and then you could schedule tasks once you're confident that you have something that's good to go. And it should be as easy as, Control A, Control C, Control V, right? Let's give it a second to run.
So real quick, Rosh, when this runs, is there like a log of errors or anything like that that happens?
Yeah, I was going to get to that. It does not log errors automatically. That is something we're hoping to build out.
Okay.
What is this? There's some kind of connection thing. So yeah, right now it does not like if your job fails, it will say job ran, but because you ran, you just failed, you know. Okay, so then maybe there's some kind of connection thing right now, but that's okay. I'll just show you the scheduler part itself. So okay, let me go to the part that I was already working on. I didn't need to start it there. Okay. So if you had this, what the heck? Sorry, guys. Okay, so you just go to the scheduler here. It's just the little calendar icon in the upper right. So then you have your jobs. You can rename it if you like. Sorry. And then down here, you can run it now just to tell if it's going to work, or you can click run on a schedule. And here you go to like, you know, if you wanted to run every week or month, that kind of thing at a given time, whatever you prefer. If you want to do something clever and do it at a different rate, you can use a cron expression. I don't know if you guys are familiar with that, but it's really like you provide some parameters in a certain syntax, and you can do like, you know, 12 o'clock on Wednesdays every month, right? Something like that, whatever works for you. I figure daily or weekly is probably fine for everyone, but if you want to mess around and have your own custom setup, you can totally do that. Good. Okay. So
Sorry, we'll probably need a little more custom on the COVID side. Do you mind opening the where we were, not before that, but just the scheduling piece one more time?
Run on.
So for the job name, we always want it to have that .Jupyter Notebook, not .R, correct?
It should say IPy-NB. Sorry, I was doing that. But yeah, if that's just the file format, because you specified the kernel, it is still running R.
Okay, that's what I thought. Just want to check. Thank you.
Yeah, good question. I don't know what that's about. Yeah, so you can put the cron expression, and then I know. Thank you. Okay. Once you're here, I guess because of this server connection thing, which I'm not sure always happens when you're doing a demo, but you will see a list of your jobs that you have scheduled. So there's two tabs here. One is called, yeah, thank you, Nicole. Over here at job definitions, will tell you all the jobs that you have scheduled for your team. So over here, you can see that I've got yeah, now it's not gonna work. You'll see like, okay, this task is done. When was it created? When was it scheduled for? And then on notebook jobs, you can see the history of what ran when. So every day, if it's running, it'll create a new row here for the input file will be the notebook. The output file could be whatever the notebook created and whether it completed or not. Again, the completion is going to be more a matter of did the job kick off and finish the notebook rather than did the job actually do what you wanted it to do. So what we would recommend is, at least for now, you can write into your code error message emails, that kind of thing. And if you like, we can talk about like providing an inbox that could help you manage those messages, that kind of thing. Yeah.
Yeah, I'll say on the COVID side, so we have our scripts have like lines of code to help us understand what the error was. And then we actually send those error emails to a Google Groups account. So that way multiple people can see the errors and address them. And you can also assign the errors to specific people out of a Google Groups account, if that's helpful to folks.
Yeah, that's a good thought. So yeah, there's no reason you couldn't do that here. You would have to authenticate, of course, but the same thing you should probably already do. And so unfortunately, I cannot show you, but my colleague scheduled a task and I was able to see that their task was scheduled just alongside mine. Yeah. Right now, there is one limitation that we are working against, which is that the file structure inside of the scheduler is higher level and does not necessarily have access to all the same files as within each specific project. And we're working with a vendor to expand that so that the scheduler account, which is at your organization level, can see all the relevant projects within your organization. So for me as a CDPHE person, I would have access to all these projects from within the scheduler, right? There would be one project mounted to my virtual machine, but the scheduler would have the entire file structure. As a result, the scheduler could drop files in multiple projects at once and that kind of thing. One of the scenarios worth imagining there is we could give an LPHA a project and they could go to that project to receive files from us on a regular cadence and pull them into whatever systems they need them for. And that way you have an automated file handoff. And you could do that for COVID, but everyone could use the same project for their own. So if the immunization team wants to hand the LPHAs a file on a regular cadence within a project, that could be, one-stop shop for Larimer or Arapahoe to get data from anyone working in the Lakehouse. Okay, so then on the topic of getting files from us, let's go to that bit. So you'll schedule a job, presumably, and let's say it's creating a file. And where would the file land? Wherever you tell it to. So, but then, of course, whoever wants to export files from the system will need to use a certain application. Now, this is maybe not as relevant to you all because you are being given extended permissions in here. You're admins on the virtual machine, so you can install, delete programs at will. You have access to the internet in your virtual machine where some users may not. You have access to your Google Drive as a result. You can even map your K drive, J drive, so on from within the local machine. So you have a lot of options as far as getting your data out of the Lakehouse into whatever other formats you want it to be. But other partners whom we do not want to give as pervasive access to will need another tool to get their data out. And for that, we have developed this export module. So if you just open this one, people can create requests to export data from the Lakehouse. You just click New Export Request, choose a file. How about this very cool block of code? Let's say let's make it so anyone on the project can download it. And you can just say text export, text export. If you submit it, you're requested to say, yes, you know what you're doing and you're going to use this properly. And you submit the request. And now over in the project, if we refresh this page real quick, you can see that export has come through as a requested export. And we can now download the file, or it's automatically approved because I requested it myself. You can approve it if you're from another team. So like if you want to make sure when Larimer is getting their data and you want to manually say yes to them when they ask for it, you could do that. And then you can download it and it'll come to your local machine where, well, here, just open another tab because it's an R script, but it'll be available for you in a way that you can access it from a local machine. Yeah. Any questions on that bit? So this would be another way for you as well if you want to get files to your local machine. If you want to get files into the virtual machine, you can upload them here if Google Drive or your K drive and your Isilon drives are not enough. Yeah, cool. Okay, so in addition to all this, I wanted to, I'll share with you guys some of these links. Just this is a quick and easy cron expression generator if you wanted to use it. And then there's also this sort of deeper dive into how Jupyter Scheduler works. I'll share the link with that, so if you're interested in the documentation there. Well, I think that's about all I had to show you guys today. I hope 30 minutes was enough, Nicole.
Yeah, of course. And I think, yeah, if you'll send that over to me as well, I can put it in the folder for everybody after this call. But thank you. This was really informative. I did have one last question before we skedaddle, which is, if we get to just the regular environment in the virtual machine, so the desktop looking environment, and not that we want to use it this way because for many reasons it doesn't make sense, but just conceptually, this space is connected to VPN intrinsically, right? So like if I were to create a task on this virtual machine for whatever reason to run, it could run with the expectation that it's connected to VPN, kind of like a remote server.
It did, are you thinking of like OIT's VPN?
Yes.
So unfortunately, no.
Okay.
OIT early on in this project said you cannot share accounts with us, and so we can't get on their VPN without jumping through some hoops. So if you wanted to access SQL servers, for example, that are managed by OIT, you unfortunately cannot from this version of SSMS here.
Okay. So yeah, we're working in and out of BigQuery in this situation then.
BigQuery, Google Drive.
Right.
Yeah, and the database is hosted in Google Cloud, so there's a couple of those that are not in BigQuery, that kind of thing. But yeah, if they are currently on like 144, migrate something to this that needs to touch 144 exactly.
Gotcha.
If the data on 144 is available, which presumably it would be because it's like CDRs or immunization data, we could automate the end goal, but we cannot automate the actual code itself because the code references 144.
Got it.
Does that make sense? Yeah.
Yeah, of course. And then, oh gosh, that made me think of something else, but it'll come to me later, and I'll ask you later. But thank you so much for this. Does anyone have any questions before I stop the recording?
Well, let me say a few more things about the VPN thing, right? So you are within a virtual private network while you're in here. You're just inside the Lakehouse virtual private network. So if you were to install Global Protect on this thing and try to go to VPN, to OIT's VPN, it will break because you'll be like trying to go to another network that you're not allowed to be in. So don't do that, one thing. But the whole purpose of the virtual machine is in a large part to make sure you're in a virtual network when you're working with these things and protected in that way. And of course, that does create some blockers. One of the things you can do, despite not being on VPN, is go to those shared drives on your local machine. You do need to use a VPN to get to those. Here, you can simply pass your credentials, and it will know. So, like, you can map a drive. Well, sure, here we go. You just put dphe.cloud instead, and you can do like users. Say connect using different credentials, and instead of using the Lakehouse credentials you logged into the virtual machine with, it will prompt you and you can provide your whatever you used for your local machine to log into. And then you can map the drives you have access to on OIT's virtual network.
Yeah, so let's say I have drives in the Data Lakehouse that I want to automate tasks through Jupyter Notebook to export to those drives that are on my virtual machine. Is there any authentication process that needs to happen there, or are the drives just native to the virtual machine so I can automate that process? So kind of like if I were on my local machine. So let's say the one issue we have, right?
Yeah.
J Drive, you have to be logged into every day. So if I were to automate a task on my local machine to export to J Drive, I'd need to make sure that I have logged into VPN and I'm on J Drive. It's the whole hoopla, you know.
Yeah.
Does this environment solve that process, that problem?
Yeah, if you, well, because if you automate it, you're automating it at the organization level, right? And the organization's always logged in, always up and running. Whatever you drop your files in here, you don't need to worry about like, was I on VPN or logged into my machine at the time? You can take a long break, put your virtual machine on shutdown and forget about it. And it will run without you and your friends can see that it did run.
Okay, but it's exporting to this Jupyter Notebook. But can it also export to like a drive on my virtual machine?
It can export to like the shared drives that you have, like these project drives. Is that what you're asking? It
kind of, but also like I know there were some drives on the virtual machine that you were showing, like you were just logging in and mapping it, and that made me think about whether or not it could export to a drive like that on the virtual machine.
I don't think you can export to like the K drive from within the virtual machine.
Gotcha.
I wanted it to do that, but again, OIT is
no,
not.
I get it.
Yeah.
But it does, there is a shared space it can export to, which is nice.
Yeah, exactly. So our hope was that these project shared network drives that are in the Lakehouse environment could, to some extent, replace what's done on K drive, J drive, like that. So like you could create SCDers files in and out for coughs, for example, and just drop them here.
Yeah. That's the dream.
Hopefully. Yeah.
Got it. Okay. Well, yeah, I'll stop peppering you with questions. Does anyone else have anything? Or do you have anything else you want to talk about?
No, I've probably bent your ear enough, but please, if you have any questions offline, or you have like, ooh, this is a cool project I want to work on, or like I said, you don't even need to be a cyst or immunization person. I have a use case for having my own database where I can create tables easily. Just shoot me a chat and we'll try our best to make it happen.
Okay, I am going to stop